Good afternoon, fifth period. How you doing?
Good.
Thank you very much. Remember, we're recording, so I'm going to ask that you keep side conversations to the very, very end. I appreciate your help. Please set up for notes. Here's our typical T fashion to set up with. I've got a protractor out. Thank you so much for getting one. We're not going to actually use it to measure anything. I grabbed it because I wanted the straight edge so that I could draw straight, pretty angles, and for no other reason. So if you don't have a protractor with you, relax. It's okay. Just draw the lines as straight as you can, all right? I've got pencil because we're going to be doing some algebra today in case I mess up. I've got some different colored pens to show you different things with, and highlighters as things get real. So let's get started with our date and title. It is the 22nd of September, and today's lecture is titled Algebra Connections. And today's Algebra Connections is going to be focusing on the angle addition postulate. Oops, let's spell postulate right. It's an O, not an I. And bisectors. There it is, the angle addition postulate and bisector. Now, several days ago, we talked about the segment addition postulate. Do y'all remember what that one was? The segment addition? What it said? Y'all remember? You're going to your notes. I love it. That wasn't segment addition. That was just talking about different types of angles, but I'm glad that you remember talking about different types of angles. So the segment addition postulate was one where we had this segment sitting there, and we broke it into a couple pieces, and we said that we could take the measure of this part of the segment, add it to the measure of this part of the segment, and we'd end up with the measure of the entire segment. Remember that one? And it allowed us to do some algebraic type stuff. That's the right word. It's not algebraic, it's algebraic. It allowed us to do some algebraic stuff to find the value of x and to find the measure of different parts of the segment. So we're going to do the same thing, but with angles, and so we have the angle addition postulate. I'm going to zoom in here on the left, and we're going to start off the title with the angle addition postulate. And the angle addition postulate says this. Now I'm going to write a bunch and then we'll draw the picture and it'll become clear. Okay? So the angle addition postulate says this. It says, if, oh, that's a horrible I. I'm sorry. If ray BD is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. I understand there's a lot of letters there. I'm going to scoot it over to the right a little bit, and I'm going to draw the picture here to the side, and you will see as soon as that picture comes up, it will make sense. I promise. So I'm going to use my protractor just to make sure my lines are nice and straight for you guys. Here's our angles. I need to put the letters that this thing is talking about. So I have A sitting over here, B is the vertex, D somewhere here in the middle, C is over here. So now we have angle ABC with ray somewhere in the middle, BD. Doesn't say anything about BD being a bisector yet. We just know that it's somewhere in the middle, and that's all we really know. So basically what this thing is telling you is this. If you take the measure of this angle right here in yellow, and you add it to the angle measure of this angle here in blue, you're going to end up with the measure of the entire angle, which is exactly what the segment addition postulate said. This one just says it for angles. Okay? Take a few seconds to jot this down, and then we're going to go right into the algebra concept. Give me a thumbs up when you're ready. Thank you. Thank you. Thank you. Más o menos. Thank you. Thank you. Thank you. Thank you. Thank you. All right, I'll keep that up there. I'm going to go ahead and start writing the next portion, but this won't go off the screen just yet. So now we're going to have our example, our algebraic example. You may see somewhere on a test or on a worksheet something that says this, given, and then it's going to give you a lot of information. It's going to tell you the measure of an angle, and then it's going to tell you the measure of another angle, but it's going to give it to you in a bunch of weird algebra. So it's going to look something like this. Measure of angle DBC equals 3x plus 4. All right, there it is. And then the directions are going to say, find the value of x. I'm going to scoot it up to cover the picture a little bit, but please remember that this whole thing is going to be referring back to this picture. So as you guys are getting ready to move through this this subject, we're starting to get to the point where we're going to be having to do proofs. I told you guys a few weeks ago that you guys are now attorneys, and you're going to be given some bits of information, and then you're going to have to prove something like who's guilty kind of thing, right? And you've got to use all the bits of information that you've been given so far in order to get there. So to get you guys ready for that and to try to help out as much as possible, I'm going to continue doing all of my algebra stuff in kind of 2 columns for you. Okay? So the left-hand column is where I'm going to write all my work. The right-hand column is where I'm going to tell you the reasons why I'm doing that work. And I want you to spell all of your algebra problems out this way in this class. Okay? I know for some of you it's going to be really tedious and boring. I'm sorry. It'll help in the long run. I promise. All right, so the first thing we know after looking at this picture and looking at what's given is that picture allows us to use this angle addition postulate, this sentence right there. Since that's where I'm starting, that literally is where I need to start. So I'm going to come down here and I'm going to rewrite out what the angle addition postulate says. The measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. And the reason for that was the angle addition postulate. I'm going to have to abbreviate postulate because I don't have enough room on my paper. All right, I'm going to take my green pen. Green means go. I'm going to underline that because we are still going. All right, next thing that I have here, some substitutions going to help me out. I know what the measure of angle ABD is. I don't know the number of the angle measure, but I know this algebra phrase that could tell me what it is if I just knew what number the letter X was supposed to be representing. Okay? So I'm going to make that substitution right now. So there's that first substitution. I'm going to continue to go along and substitute in for everything else that I know. And all of this stuff was substitution from given. Because all of this information, I didn't just make it up and pull it out of my hat like a magician with a rabbit. Whoops. I got it from the given statement up above. Okay? So far, so good? All right. All right. Next up on the algebra train stop is the combination of like terms. Okay. And so we're looking for like terms. A reminder, like terms are things that have the same variable, have the same letter. And as you move forward in your study of mathematics and go into Algebra 2, you need to make sure that those variables have the same exponent, the same power, the same little number sitting on top, okay? If they don't, they're not like terms, and you can't combine them, all right? You won't see that any here in class, but I just wanted to get it in the back of your head. So 7 x's plus 3 more x's. I'm the world's worst girlfriend ever. I now have 10 x's. Thank you for laughing at that joke. It's super lame. And then the numbers are themselves like terms. So 6 plus 4 is 10. And I end up with something that looks a lot like that. Did you get it?
Huh?
Did you get it? You got my joke?
No, man. It's so, I was saying, like, you can probably go back in the videos and see, like, how many, like, jokes you said throughout the year. Like,
And maybe make them better?
yeah, like, maybe next year, maybe next time.
Next year that joke won't bite as much. All right, moving on the algebra, I need to undo this addition. Always undo your addition subtractions first. So undo the addition of 10. So we're going to use subtraction. I need to get rid of 10, so that's what I'm subtracting by. What I do to one side, I have to do to the other side of the equal sign. So that's going to leave me with 10x equals 120. Here I want to undo the multiplication. So between the 10 and the x, I don't see any kind of symbol, but if I don't see a symbol, I have to assume it's multiplication. So I'm going to undo multiplication. The opposite of multiplication is division. So we're going to divide, and we're trying to get rid of that 10, so we're going to divide by 10. Notice now my little bars totally make sense now. As soon as we got fractions involved, those little spacer bars helped us keep track of what we were doing and we didn't get lost inside the fraction. 10 divided by 10 is 1, so it leaves us with just the x because that's a multiplication division kind of thing. 120 divided by 10 is 12. You could tell my brain was already on the answer, right? Yeah. And so that was just straight up division. All right. So far, so good, yeah? Seems pretty easy? Feeling more comfortable with the algebra stuff? Good. But what if the question wasn't just find the value of x? What if this was a skill check and I decided to be mean to you guys and say not only find me the value of x, but find me the value of the measures of angles ABD and DBC? Which means this step where we have found x is not the end. It's more like a yellow light. It feels like the end. We're kind of slowing down a little bit, but there's no cars coming, and so we're going to step on the gas and speed through the intersection, right? Okay, please take driver's ed. I never did. Don't use me as the how to drive example. I will get you speeding tickets every single time. All right, so since I have two angles that I'm looking for, I'm going to do them at the same time. So take your workspace and kind of divide your workspace in half, because we're going to do the same things to both of these things at the same time. Okay? And it's just going to conserve space a little bit. So I'm going to start with the measure of angle ABD, which I was given as 7x plus 6, and the measure of angle DBC, which was given to me as 3x plus 4, and I said those were given to me, so my rationale is going to be it was given. Okay, we still got green lights, we can still keep going forward. I'm going to use some substitution, but this time I'm going to substitute what I know for x, which is 12. Okay? So everywhere I see an x, I'm going to put a 12, and I know that this is 7 times x, so I'm going to use parentheses to show that multiplication. And I'm going to do that for both little phrases that I had there. There we go. So far, so good. We are almost done. Now, if you guys have calculators in front of you, I'm going to ask you, please, please, please double check my arithmetic. My arithmetic, the adding, subtraction, multiplication, dividing, because I'm very, very bad at doing 9 plus 3 equals 10. Okay? That's how I add in my brain. I don't know. I don't know. Don't ask. So please double check my arithmetic, my addition, subtraction, multiplication, division as I go along. That's 84. I think. Oops. This is 36. I use multiplication here. I only made one change. When in doubt with your algebras, if you're worried that you're going to skip a step or not sure where you are, or you're in a place where you feel you're going to be distracted a lot, trying to do your homework with, brothers and sisters and nieces and nephews and cousins all bouncing around the living room while you're trying to study at the kitchen table, totally write one step at a time and write the reason why. It'll help you out. Now I'm going to do some addition, and I should be done. 90 and 40. 1. Wait. 40? 40. Yes? 36 plus 4?
That's
40. Okay.
6 and 4 are equal.
6 and 4 is 10, and then you carry the 1 fork. Got it. Awesome. I did everything they wanted me to do. I found the 3 values they wanted. There's the x, there's the ABD, here's DBC. So I am now done. But miss, you say, you haven't gone over angle bisector and class ends in less than 10 minutes. How are you going to do a full example on angle bisector in 10 minutes or less? To which I say, I'm not. I'm going to leave you with this question. The question is, does this blue pen work? The question is, what if the problem stated ray BD is the angle bisector of angle ABC? How does that change this problem? The only thing I'm really changing is, instead of giving you the full measure of the big angle, I'm telling you that this ray bisects angle ABC. What does that imply for the little parts that this thing is getting broken into? Let's go up to the picture real quick. So here we have angle ABC. Here we have ray BD. And it's the bisector, so it goes through the It just takes some time, little girl. You're in the middle. It goes right through the middle. You're never going to forget that now. The bisector goes through the middle, which means it cuts the angle in half, which means the measure of this angle is half. And how does it relate to the measure of this other angle? It's half of this, the yellow angle. How does it relate to the blue angle? Their measures are the same. So if the measures are the same, how do we write that algebraically? If they're the same, we say they are equal. And so your algebra starts there. Algebra starts there. And then all the different algebra stuff that you need to do to get down to the bottom of what x is, goes from here. Does that make sense? Does that make sense? All right. Fantastic.